Okay, now recording. All right, so continuing on one section a day. So let me try to share the screen here. Okay, so we're on to our derivative shortcuts, derivative rules. Okay, so again, the modified calendar, we are up to here. So 9.5, sorry, maybe you can't read that. It's 9.5. All right, so one section a day. So 9.5, give you a quiz later on today. Then next week, 9.6, 9.7. Week after 9.9, then the third test on chapter 9, and then we have a week off for spring break. Okay, and you've already seen a couple of tests, so you know what my tests are like and what it's all about. So the next test is just a chapter 9 test. You submit all of this homework on the day of the test. I must get at least 70% of the homework in order for me to grade your exam. If I don't get at least 70%, then I don't grade your exam. And that's really not that hard to do, considering I end up doing a huge percentage of the homework anyway, right? In fact, some homework assignments, I end up literally doing 70% or more. So if you just kind of keep track of everything I do in class, that's almost sometimes 70%, or I end up doing close to 50% or whatnot. Okay, so we'll do today's lesson, and then after I'm done with that, I'll give you the quiz, and then that'll be it for this week. Okay, so more derivative rules. Okay, we have the product rule, my page 587, and quotient rule, my page 585. Okay, so I'll show them to you again a little bit slower. You can put these on your next cheat sheet. Product rule. Okay, as you can see, it's not as easy as you might think. You might think, oh, if I have a product, something times something, how about if I just take the derivative of the first function times the derivative of the second? Doesn't work that way. We state it without proof. Again, if you were to take the Math 110 series or 100 series, they might prove it to you. Okay, but if you have a product u of x times v of x, it looks like f prime of x is u v prime of x plus v u prime of x. Okay, so in words, you just copy the first function and you multiply it by the derivative of the second function, plus the other way around, you switch it. Second function times the derivative of the first function. Okay, I'll use that language quite a bit. So definitely put this on your next formula sheet, your cheat sheet for the test. It's called the product rule. Product means you're multiplying, right? Something times something. So u v prime plus v u prime in short. Okay, you just copy the first function and you multiply it by the derivative of the second, plus the other way around, second function times the derivative of the first. And I'll show you a bunch of those. Okay, that's the product rule. Then the quotient rule, quotient means you're dividing, right? Something divided by something. That looks even worse on page 585. Put this on your next cheat sheet. So f of x is a quotient, u of x divided by v of x. Okay, look at how messy the formula is for a quotient. Again, it's not as easy as just take the derivative of the top divided by the derivative of the bottom. That's not the way it works. Okay, let me put this down just for a moment because it's too heavy for me. I'm going to move this over. All right, so it goes v of x, u prime of x. It's the bottom times the derivative of the top minus the other way around, u of x, v prime of x. Top times the derivative of the bottom. The whole thing divided by the square of the denominator, v of x quantity squared. Okay, so u and v. Okay, so again, sorry, I can't really coordinate myself to do this, but bottom times the derivative of the top minus the other way around, top times the derivative of the bottom, all over the square of the denominator. And I'll show you a bunch of those. Okay. And one thing I'll point out quickly, since it's the formula, you will notice for just about every single one of the quotient rules, that thing matches that. You might be tempted to cancel these out. You're not allowed to cancel them out because there's a minus sign there. Okay, happens all the time. Students will forget. They say, oh, I see the same thing here and here. Why don't I just cancel them out? Okay, you're almost always not going to be able to do that, just to let you know. Okay, and I'll demonstrate that for you, show you what I mean for that. Okay, this is the quotient rule. Okay, so I was going to show you a bunch of even product rules. Then you do the odds, of course. And then a bunch of quotient rules. Okay, by the way, they will not be on today's quiz. Today's quiz will be on last time stuff. Much, much easier, in my opinion. Of course, my opinion doesn't really count if I say it's easier because, I'm the teacher, I'm supposed to know it. But I think it's easier for students is what I mean. Okay. All right. So let's get started. So what do we have here? All right, so we're up to here, right? So about halfway through chapter 9. 9.4. So 1 to 26, odd, 39, and 43. So we have to go up to 43. Okay. So here we are in my book. And for those of you who aren't getting the book, it's my page 587. Okay, find the derivative. Sometimes it says simplify, sometimes it doesn't. Okay, if it's really, really messy, I won't have you simplify. Okay, language for 9 and 10. Slope of the tangent line, derivative. Instantaneous rate of change, derivative. So again, the answers to A and B are going to be the same. Okay, 11. Okay, don't get scared by that D notation. It still means derivative. So like 11, it says dP dQ, or 13 dy dx, or ds dt. It still means derivative. Okay. And then on the next page, dy dx. Okay, in fact, if you look at 18, 19, and 20, those are all the different variations of to write the derivative. Dy dx, y prime, f prime of x. It all means the same thing. Okay, 21, 22, slope of the tangent line, derivative. Instantaneous rate of change, derivative, right? Write the equation of the tangent line. Okay, we're going to see that over and over, as we said, right? So we know what that's all about. Y minus y1 equals m times x minus x1. Okay, and again, if you ever see the graphing calculator icon, right? If you see this, ignore that part. Now, we still might be able to take a derivative, but don't worry about doing any graphing calculator stuff. And same thing there. Okay, so 31, 32, 33. And let's see, how far do we have to go again? 43. So we have 39 and 43. So I'll just show you 39. Okay, there's 39. Looks like a little mini word problem. And 43, something about revenue. And 40, yeah, it continues over there. So there we go. Okay. So let's get started and I'll show you a bunch of problems. And let me check the chat. Okay, some people here, some people here. Okay, that's fine. Anybody else I missed for attendance, if you came a little late, just put it in the chat so I know. All right. So 9.5, page 588. So I'll do the evens and you do the odds. So I'm going to do 2, 4, 6, and so on. All right, so number 2, y equals 5x plus 3, x squared minus 2x. Again, I should say my number 2, which might be different than yours, but you're still learning the material. Okay, so we're doing this new product rule. Okay, if I call this F and I call this G, it's F G prime plus G F prime. So the derivative of y prime is copy the first function, 5x plus 3, and then multiply by the derivative of the second. So the derivative of this thing is 2x minus 2. Plus second function, copy the x squared minus 2x, times the derivative of the first function, which is 5. Okay, that's the product rule. So again, you have to force yourself to not do the quote unquote obvious thing. The obvious thing you might think of is, oh, why don't I just take the derivative of the first function times the derivative of the second? I mean, that's what I did for sums and differences if I had a plus or a minus, but not for a product, not for a quotient. It's not that easy. Okay, so notice you copy the first function, multiply by the derivative of the second, plus the other way around, copy the second function, times the derivative of the first. And then it's just some algebra after that. So let's see, I just FOILed this out, right? So 10x squared minus 10x plus 6x minus 6. And distribute this, 5x squared minus 10x. Gather like terms. So these two give me 15x squared. And then that one, and that one. Negative 10 plus 6 minus 10 is a negative 14x. And then the only number I have is negative 6. So there we go. Okay, 4 is pretty bad, so I won't bother multiplying it out. Okay, x to the 12th plus 3x to the 4th plus 4 times 2x cubed minus 1. So product rule. Okay, copy the first function. So just copy x to the 12th, blah, 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 times the derivative of the second function. So what's the derivative of 2x cubed minus 1? 6x squared. Plus second function, copy the second function, 2x cubed minus 1, multiplied by the derivative of the first. Okay, so the derivative of x to the 12th, 12x to the 11th. Derivative of 3x to the 4th, 12x cubed, and the derivative of 4 is 0. So there we go. Okay, I just put etc., meaning you can multiply the rest out. Now, of course, when it comes to a quiz or test, you don't get to write etc. Only I get to write etc., meaning the rest is algebra 1. You know how to multiply it all out and gather like terms, but I'm focusing now on the calculus, on the new stuff, and you can do the rest of that later. Okay, now for something as bad as number 6, definitely don't multiply it out. It's really, really long. So that's why in the directions, I'm sure they just say, okay, once you figure it out, then stop, right? So for number 6, right, find a derivative, but do not simplify your answer because it's so bad. Okay, you notice all the problems are pretty much paired. So notice if I do 2, you should be able to do 1. If I do 4, you should be able to do 3. If I do 6, you should be able to do 5, and so on. They're always paired like that. Okay, 6, this mess times this mess. So dy dx, okay, you say, what is dy dx? Derivative. So is y prime, so is f prime of x. I'm using all the symbols so you can get used to all of them. All right, so copy the first function. Careful, don't take the derivative of the first function, just copy the first function. And then multiply it by the derivative of the second function. Okay, so here we go. Derivative of this is 15x to the 4th, right? And then the derivative of this is negative 16x cubed plus 9x squared. And we know this is constant. The derivative of negative 8 is 0. All right, so first times the derivative of the second plus, notice how I scroll down, so to speak. You don't have to keep going all the way out to the right. If it gets too far out your paper, you run out of space. It's okay to scroll down, you know, kind of like on your computer screen. When you reach the far right, then it just scrolls back automatically. So you can scroll down, so to speak. Okay, plus the second function. Copy the second. Careful, not the derivative of the second, just copy the second function. 3x to the 5th, blah, 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 blah. And now times the derivative of the first function. So here we go. 81, 9 times 9, x to the 8th, minus 49, x to the 6th, minus 6. Okay, so that's the way the quotient rule works. Okay. All right, 8 gets pretty bad because you've got some roots in there. So before we go on, we have to fix the roots. So the original looks like this: x squared plus x plus 1, cube root of x minus 2 radical x plus 5. Okay, so cube root of x means I write it as x to the 1/3 power, right? Write it as a fractional exponent. The power is on top. What's the power? It's 1, understood. The root is 3. This one, the power is 1. And if you don't see any number here, then we know that it's square root. So 2x to the 1/2. All right, so now it's ready to go. So y prime, copy the first function, and then times the derivative of the second. So 1/3 x at a negative 2/3. And what's the derivative of this? 1/2 times negative 2 is negative 1. So it's negative 1. You don't have to write the 1, just negative x to the 1/2 minus 1. 1/2 minus 1 is a negative 1/2. Okay, plus second function. So copy the second. So if I'm going to copy the second, I might as well copy the original, not this new thing. So cube root of x minus 2 radical x plus 5. I just copy that. And then times the derivative of the first function. So derivative of x squared is 2x, plus derivative of x is 1, and derivative of 1 is 0, so you don't have to write it. And there we go. And again, you can just stop there for this one. So what about simplifying this? Yeah, we can, but this is so long, you know, it's not really worth it, in my opinion, in this case. All right, for number 10, now they give me a particular point. Let's look back at the directions. Okay. So at each indicated point, find the slope of the tangent line and the instantaneous rate of change of the function. So the answers to A and B are the same, derivative, and then just plug in whatever they give me. Okay. So I do the same thing, except after I find a derivative, I plug in. All right, so here we go, product rule. Y prime, first function, copy it, times the derivative of the second function. So derivative of x squared is 2x. Derivative of negative 4x is negative 4, and the derivative of 1 is 0, so don't write it. Plus second function, x squared minus 4x plus 1, times the derivative of the first function, 3x squared. Okay, now I plug in 2. And you might say, what about the negative 15? That's for y. So if I saw any y's, I'd plug in negative 15, but there are no y's, so I just plug in 2. So put 2 right there, and right there, and right there, and right there, and right there. Okay, but notice if I put a 2 right there, right, I get 4 minus 4, which is 0. And 0 times that is 0. So all of this gets wiped out. Very nice. Now this does not get wiped out. So put a 2 here, 2 squared minus 4 times 2 plus 1 times 3 times 2 squared. Okay, so clean that up. That's 4 minus 8 plus 1 times 3 times 4. So 4 minus 8 is negative 4 plus 1 is negative 3. So negative 3 times 4, which is negative 36. That's my slope. So therefore, the answers to both A and B are negative 36. Okay. All right, I'm jumping to 24. The reason why I'm jumping to 24 is I want to do all the products first before I do the quotients. Okay. Because if I just literally go in order, then I have quotient rule, quotient rule, quotient rule, right? But I'm going to just make sure I do all the product rules first. So that's why I'm jumping ahead to 24. Okay, write the equation of the tangent line at the indicated point. Okay, so we know what that's about. Y minus y1 equals m times x minus x1, all that stuff. And check the reasonableness by, okay, don't do that, right? So never mind about that. Okay, so I'm trying to do all the products first. Now, notice this time they did not give me the y value. How do I get the y value? 75. I plug it in. Okay, so put 2 right there, and right there. So 4 times 2 squared plus 4 times 2 plus 1 times 7 minus 2 times 2. Clean it up. 4 times 4, 16, plus 4 times 2 is 8, plus 1. 7 minus 4 is 3. Okay, 16 plus 8 plus 1 is 25. 25 times 3, 75. Okay, so the point is 2 comma 75. Right, so point slope. So I already know it's going to be y minus y1, y minus 75. Even at this stage of the game, I know it's y minus 75 equals something times x minus x1, x minus 2. Okay, so how do I figure this out? Slope. How do I find slope of the tangent line? Derivative. Okay, so let's find the derivative of this thing by the product rule. All right, so copy the first function, 4x squared plus 4x plus 1, and then times the derivative of the second. So the derivative of the second function is -2. The derivative of 7 is 0, right? Derivative of -2x, that's a linear function, be -2. Plus second function, 7 minus 2x, times the derivative of the first. So what's the derivative of that? 8x plus 4. And there we go. Now I plug in 2. Do I have to plug in 75? Well, I plug in 75 if there were any y's, but there are no y's, so don't worry about it. Okay, so plug in 2 right there and right there, and every time I see x, there and there, and clean it up. So 4 times 2 squared plus 4 times 2 plus 1 times -2, 7 minus 2 times 2, 8 times 2 plus 4. Okay, you may recognize some of this we've already done when I did the calculation back up here, right? We sort of already did a lot of it. Well, like I recognize this is still 16 plus 8 plus 1. We just did that, right? That's 25 times -2 plus 7 minus 2 times 2. We did that up here somewhere, didn't we? Yeah, so that's what, 3? 8 times 2 is 16 plus 4 is 20. So 25 times -2, -50. 3 times 20 is 60. Add them up, 10. So 10 is my slope. That's my m. So I'm all set. Point, slope. Y minus y1, y minus 75 equals m, 10, parentheses x minus 2. You may stop right there, meaning we're focusing so much on the calculus. We already did all this. We could make it look nicer, y equals mx plus b. That's for Algebra 1 students to do. You already know how to do that. We're going to focus on the calculus and not keep going. So you may stop right there if you wish. Okay. Okay. All right, so that's the product rule. And now I will show you the quotient rule. So again, let me show you what we're up against for today's lesson. You have a product rule. It's on my 584, some equivalent page on yours. Okay. If you have a function of the form u of x, v of x, u v prime plus v u prime. First function times the derivative of the second plus the second times the derivative of the first. Put it on your cheat sheet. And put this on your cheat sheet. Quotient rule, a little bit harder. U of x divided by v of x. So it looks like bottom times the derivative of the top minus the other way around, top times the derivative of the bottom, all over the bottom squared, denominator squared. Okay, quotient rule. So the quotient rule ones start at problem 11. So now I'm going to go back and do quotient rule problems, right? Something divided by something. All right, so number 12, c of x is 2x cubed divided by 3x to the fourth plus 2. All right, so the rule goes as follows. You take the bottom times the derivative of the top, 6x squared, minus the other way around. So one nice thing about the product rule and the quotient rule is it's you do one function and then times the derivative of the other, and then you switch it around. Okay. For the product rule, the joining symbol was a plus. For the quotient rule, the joining symbol is a minus. Okay. Again, we're stating this without proof. Okay. If you were to take, let's say, the 110 math series, they might prove it to you. So bottom times the derivative of the top minus the top times the derivative of the bottom. So the derivative of the bottom is 12x cubed, all over the square of the denominator, 3x to the fourth plus 2 quantity squared. Okay. Now, that's the calculus part. Usually it's not worth multiplying out the bottom. Don't multiply at the bottom. It is usually worth it to multiply at the top because sometimes stuff cancels out or combines. Now, this is what I was talking about earlier. You look at this and look at this, right? And you might say, hey, can I cancel these out? The answer is no, okay, because you're subtracting. You don't cancel across a subtraction symbol. Okay. Now, if this thing weren't there, if it was just like this and you're not adding or subtracting anything, then yes, you can cancel one of these with one of these. But once you add or subtract something from algebra, right, you're not allowed to cancel this out. That will always happen in the quotient rule because it's already in the formula, as I mentioned, right? See how this v of x and that v of x squared, you might think, hey, maybe I can cancel these out. The answer, no, you're not going to be able to cancel them out. Okay. All right, I just cleaned up a little bit of algebra here. So distribute 18x to the 6 plus 12x squared. And multiply that out, that's negative 24x to the 6. So as you can see, the x to the 6 combines. So best final answer is negative 6x to the 6 plus 12x squared all over 3x to the 4th plus 2 quantity squared. Right, so that's a quotient rule. Something divided by something. Okay, 14, t cubed minus 4 divided by t cubed minus 2t squared minus t minus 5. Okay, notice the notation ds dt. The nice thing about this notation is it tells you right away what the variables are, s and t. But if I just write like y prime, then you might say, well, what's the second variable? Yeah, we think it's usually x, but it doesn't have to be. But ds dt tells me, oh, it's s as a function of t. Okay, so anyway, here we go. Copy the bottom times the derivative of the top, 3t squared, minus the other way around, top, t cubed minus 4, times the derivative of the bottom, 3t squared minus 4t minus 1, all over the square of the denominator. So t cubed minus 2t squared minus t minus 5 squared. Okay, for this particular one, I would stop. That cleaning up the top is very, very messy. So just leave it. Okay, now on a quiz or an exam, if you're ever not sure, should I keep going or not, you can always ask me. And can I cancel this with this? The answer is no, because of that minus sign right there. Okay. So this is always going to match that. That's the way the formula worked. Okay, but you're not going to be able to cancel that out unless this somehow cancels out to be 0. Okay, 16. The problem said 200x minus 100x over 3x plus 1. I think it's easier if you change this to a plus. So see how I have it in red a little bit? It's supposed to be a minus. I'm going to make that a plus and make this a negative. I think it's easier to explain it in that fashion and keep you from getting mixed up from the signs. Okay, so and if you look at 16, see how it goes minus 100x? I made it a plus and put the negative with the 100x. That's the same thing, right? All right, well, this one's easy. You don't have to do any quotient rule with that. That derivative is 200 plus. So this thing I have to do the quotient rule. Okay, so bottom times the derivative of the top. Derivative of negative 100x is negative 100. Yes, that's supposed to be minus temporarily. It's going to be a double negative. Minus the top, negative 100x, times the derivative of the bottom, which is 3. And yeah, that's a minus and a minus. So minus and minus, that's what lets me in red change it to a plus now. Over 3x plus 1 squared. Can I cancel 3x plus 1s? No. You can't distribute, and you notice a lot of cancellation. Okay, so leave alone the 200. So 3x times negative 100 is negative 300x. And 1 times negative 100 is negative 100. And this is all plus now, so plus 300x, and 300x cancels out. So final answer, 200 minus 100 over 3x plus 1 quantity squared. That's final answer. Okay. All right, and let me raise this up again quickly for focusing purposes. If you say, you know, it's out of focus, so you can look back at the video if you wish. Yeah, whenever I do this, I know I go kind of fast, but of course you can always pause the video, stop, rewind, fast forward as much as you want. So as soon as I just get a sliver of time where it's kind of focused, you can always pause the video. And there we go. Okay. Okay, 18 looks pretty bad. Two radical x minus 1 divided by 1 minus 4 radical x cubed. Okay, so in order for me to do that one, I need to change this to x to the 1/2 power. This one is x to the 3/2 power root. So 3 over 2. And then I do it. Okay. All right, so here we go. dy dx means derivative. Bottom times the derivative of the top. Derivative of the top is 1/2 times 2, which is 1, x to the negative 1/2. Minus the top, 2x to the 1/2 minus 1, times the derivative of the bottom. Derivative of 1 is 0, so don't write it. 3/2 times negative 4. 3/2 times negative 4 is negative 6. X to the 3/2 minus 1 is 1/2. All over the square of the denominator. So 1 minus 4x to the 3/2 squared. And for this one, you can stop. It's so messy, you know, it looked pretty bad. I mean, it already looks bad. It'll look worse if I try to write them back with all the radicals and so forth. So as far as calculus is concerned, we're done. That's it. You can leave your answer like that. Okay. All right, so 22. Slope of the tangent line, derivative. Instantaneous rate of change, derivative. So once again, A and B, same answer. And they give you a point, 2 comma negative 1/2 or whatever. Okay. All right, so quotient rule. Copy the bottom, multiply by the derivative of the top. So x squared plus 2x. Derivative of the top is 2x minus 4. Minus the other way around. Top, x squared minus 4x, times the derivative of the bottom, 2x plus 2, all over x squared plus 2x squared. Okay, and again, watch out. You might say, hey, that's the same as that. Can I cancel them out? No, you're not allowed to from right here. All right, now I'm plugging in 2. So everywhere you see x, where's the whole bunch? There, they all get a 2. But notice very nicely, if I put a 2 right there, 2 times 2 is 4, 4 minus 4 is 0. That wipes all of this out. So I can ignore all this stuff. Okay. Not anything else, but at least we got rid of that. Okay, 2 squared minus 4 times 2, parentheses, 2 times 2 plus 2, all over 2 squared plus 2 times 2 quantity squared. Okay, so there's a lot going on here. So that's 0, right? 2 times 2, 4. 4 minus 4 is 0. 0 times that is 0. So negative 4 minus 8. Negative 4. 2 times 2, 4 plus 2, 6. And then the bottom, 4 plus another 4. So 4 plus 4 is 8. 8 squared. Okay, double negative, negative, negative. So that gives me 4 times 6, 24 over 64. Divide out 8, that reduces to 3/8. Okay, so that's the answer to A. That's also the answer to B. Both of them, the answer is 3 over 8. Okay, then 26. Then I'm almost done. (26) Write the equation of a tangent line. All right, same thing. Y minus y1 equals m times x minus x1. Right. Notice they do not give me the y coordinate. How do I get the y coordinate? Plug it in. So here's the function. So sometimes they'll say, 2 comma 5, but they don't give me the 5 or whatever. Plug it in. So put a 2 here, 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 and here, and grind it out. So 2 squared minus 4 times 2 divided by 2 times 2 minus 2 cubed. So this is 4 minus 8 divided by 4 minus 8. Well, anything divided by itself is 1. Right? So 2 comma 1. So that's my point. So y minus y1 equals the slope x minus x1, x minus 2. So even at this stage, I already know it's going to look like this. Y minus 1 equals some slope, x minus 2. So now I have to figure out the slope. How do I find slope? Slope means derivative. That's the hard part. Okay, so quotient rule. Copy the bottom times the derivative of the top. Derivative of the top is 2x minus 4. Minus the other way around. Top, x squared minus 4x times derivative of the bottom, 2 minus 3x squared, all over the square of the denominator, 2x minus x cubed squared. Now I plug in 2. Everywhere you see x, put a 2. And once again, this is all cancels because 2, a lot of the arithmetic is the same as over we did back here, right? 2 times 2 is 4. 4 minus 4 is 0. 0 times that is 0. So I can just ignore all of this. That's all 0. Okay, negative. Put a 2 there, 2 there, 2 there, 2 there, 2 there, right? So 4 minus 4 times 2 is 8. 2 minus 3 times 4, 12. So I have a negative, negative 4, double negative, positive 4. 2 minus 12 is negative 10. The bottom is 4 minus 2 cubed is 8. So 4 minus 8 squared, that's negative 4 squared. Negative 4 squared is 16. So negative 40 over 16 divided top and bottom by 8. Negative 5 halves is my slope, my m. Okay, so the equation of the tangent line, y minus y1, y minus 1 equals m, negative 5 halves, times x minus x1, x minus 2. And that's my answer. And there we go. Okay. Okay, let's see. Question about what happened to 1/2. I'm not sure what you mean there. What happened to the half? Okay, so in the chat, I have a question about what happened to the half. I'm not seeing where the half is that I missed, or you can check with me later, or which problem are we talking about? Problem 22. I think, are you talking about this -1/2 here? For 22, yeah, if that's what you mean, the y coordinate, it's not used. Okay, now if it said the equation of the tangent line, then yeah, I'd have to do the same thing as over here. Okay, but it just asks for the slope. So once you find the y prime, you plug in x equals 2, and yes, you do plug in y as -1/2, but there's no y's anywhere, right? So there's nothing for me to plug in there. I sure plugged in 2 all over, plug in 2 here, 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 all over. And if there were any y's, I would definitely plug in -1/2, but there wasn't any. Okay, and yeah, if it said write it in the equation of the tangent line, then yeah, y minus y1 equals m times x minus x1, just like this one over here. But they didn't tell me to do that. They just said find a slope. Okay, I found a slope, 3/8. So that's it. So yeah, in this particular case, I never needed to use the -1/2. Okay, so I think that's what you mean. Okay. All right, folks, that was pretty much it. Okay, you do have 2 word problems at the end. I wasn't going to do them because I'll just talk about it, and they're odd problems, which means you actually have the answers in the back. But even if you don't, I'll just tell you what to do, and then I'm done. I'll stop and go ahead and give you the quiz. Okay, 39 and 43. $39. Okay, they give you a cost function in terms of price. C of P, C is cost, P is price. 8100 P divided by 100 minus P. Find the rate of change of C with respect to P. Take the derivative. That's all. So it's not really a word problem. It's kind of a mini word problem. You see all those words, but if you just cut to the chase, it means take the derivative. Rate of change of C with respect to P, or dC dP. Okay, bottom line, just take the derivative. And 43, revenue, blah, 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 blah. Well, they give you the formula, right? R of X is equal to, it looks like a product, 25 plus X times 300 minus 10X. X is the number of additional people above 25. Find a marginal revenue. Aha, what does that mean? Derivative. Okay. But one thing you have to watch out for. So take the derivative, but okay, I can't write this down because I'm holding a book, so you have to write this down on your own for me. Look carefully at the wording. Find a marginal revenue if the group contains 30 people. It says X is the number of additional people above 25. A little bit tricky. X is the number above 25. Therefore, if it says 30, what do I plug in for X? One more time. X is the number of additional people above 25. So how many additional people above 25 are there if we have 30? There'll be 5. Okay, so jot down in your notes for question number 43. After you take the derivative, plug in 5, not 30. Okay, so it's a little bit tricky. The interpretation is the number above 25. So if you have 30 people, that's 5 above 25. So maybe just jot down in your notes for question 43. I get 43 there. You can't show it, right? So use the product rule, take the derivative. So put down, take the derivative, but then plug in 5. Don't plug in 30, plug in 5. And that's pretty much about it. Okay, I'm done, folks. So any quick questions? And if not, we'll go straight to the quiz, and then that'll be it. Have a good weekend. Okay, so any quick questions, please? You can either unmute yourself or put it in the chat. All right, here we go. So here's the quiz. I hope you should find this fairly easy. So get your cell phones out or be ready to do a screenshot. Pretty straightforward. One is easier than two. Find the derivative of each function. Number one, y equals 4x squared minus 7x plus 9. Pretty straightforward. Two is a little bit harder. You have to set it up first. Number two, f of x is 1 over x minus 2 radical x. Okay, I'll say something quickly about number two. Your final answer should not have any negative exponents. And it should have a square root. That's a hint for number two. Okay, so change this to x to something. Change this to x to something. So number one should be straightforward. Two is a little bit harder. Write it as x to something. That's x to something. And after you take the derivative, change it back into its proper form. Okay, I'll hold it for maybe another 10 seconds and then I'll make it disappear. Go ahead and get started. Some of you are probably already finished, but hang in there. All right, I will assume everybody has it now. So go ahead and get started. Let me set up your breakout rooms and your groups. So as usual, put your first and last name and first and last name of everybody else in your group, then email it to me, and then that's about it. Okay, it looks like you'll have either 4 or 5, maybe 3, but mostly 4 or 5. Okay, you should have an invitation to join your group. So everybody please join your group.